Hi everyone, it's Miss Rose. Thanks for joining me to work on solving quadratic equations. There's definitely going to be one problem on your next honors assessment that involves setting up a proportion, and when you solve it, you have to solve a quadratic equation. It's also a skill that's going to be really useful next year in your Algebra 2 class. So I would love it if you would try these problems on your own and use the video for whenever you need a hint. Might be a good idea to get your hint, pause it, see how much you can do on your own, and then keep watching and just take the help that you need. So let's take a look at problem number 1. These get increasingly more difficult as you go. So as you know, when you're solving a proportion, the quickest way to solve is just to cross multiply. So we have 3 times 6 is 18. And then I have x times x plus 7. I don't want to make any mistakes, so I'm going to write it out like this so that I can use the distributive property. So step number 1 that you need to make sure that you understand is what you get when you multiply x times x. It's going to be x squared. Then here's something that people forget to do. They get so proud of themselves that they remembered the x squared that they forget to multiply the x by the 7 also. So that's 7x. All right, how do you solve a quadratic equation? There's 2 good methods, the quadratic formula and factoring. The benefit of the quadratic formula is it works every time, but the benefit of factoring is that it's a lot quicker. So all of the ones that I'm going to be giving you this year are ones that are going to be factorable. So for either method that you use, you need to get your quadratic equation equal to 0, and right now ours is equal to 18. So let's take that 18 and subtract it. It's kind of weird because there are no like terms with the 18, but that's okay. We'll just tack it on the end. So x squared plus 7x minus 18. And then what we need to do is we need to factor. So we need to come up with what 2 numbers multiply to give you negative 18. Because I know that in order to get x squared, it's going to be x times x. And then 18, you want to think about whether it's going to be 18 and 1, 9 and 2, or 6 and 3. So this middle number here is really just the one that you use to check. So it's negative 18. So if I go plus 9 and minus 2, if I multiplied it back out, I'd have 9x minus 2x. And that's where that 7x comes from. So that's the combination that works. All right, and then the final step in order to actually solve and see what x is you need to use the zero product property. So what that means is anything times 0 equals 0. So if you have 2 numbers multiplied together to get 0, one of them has to be 0. So you need to figure out what x is to get that factor to equal 0, and then you need to figure out what x is to get that factor to be 0. So most people just do this in their head by taking the opposite. So x plus 9, x has to be negative 9, x minus 2, x has to be positive 2. Because if you plugged it back in, you'd get 2 minus 2 is 0 times 11. If I plug negative 9 back in, I'd get 0 times negative 11, which is also 0. In this case, both solutions work because there's no geometry problem to plug these back into. If there was a triangle or something, and x represented a side length, then x would not be able to be negative. So look out for that. Sometimes you have to cross one out. Sometimes even you cross out both. Sometimes both work. All right, so that was the first one. That's the basics of what we're going to be doing to solve these equations. All right, hopefully you gave the second one a try. It is going to work out kind of the same way. We've got 20. And then here's where it gets more challenging. We have x plus 4 times x plus 12. So how do you multiply that out? These are called binomials because there's 2 terms, bi like bicycle, binomial. So when you multiply 2 binomials together, some people just use the distributive property. And some people like to use, sometimes it's called the box method or the area method. They'll do a little visual of x plus 4 and x plus 12. The nice thing about this method is it really helps keep you organized. So x times x is x squared. X times 4 is 4x. 12 times x is 12x. 12 times 4 is 48. And hopefully you notice that these are like terms. So x squared 12x and 4x is 16x plus 48. So 20 equals x squared plus 16x plus 48. What did we say in the last problem? In order to solve a quadratic equation, we need to get it to equal 0. So I'm going to go minus 20. This time there is a like term that I can combine that with. I have 0 on the left, and then I have x squared plus 16x plus 28. So I need to think about my factors of 28. Usually 7 and 4 is what comes to my mind first, but that's not going to give me 16. So let me switch colors here for a second. So I want my x squared, that's going to be x times x. And then 28, let's see, if it's not 7 and 4, there's 14 and 2. Oh, 14 and 2, that adds up to 16. So that's my combination that works. It's positive 28, so I'm going to go positive 14 and positive 2, because if I multiply that back out, I'll get 14x and 2x, which adds up to 16x. All right, so if we use our zero product property, x needs to be negative 14 because negative 14 plus 14 is 0, and x needs to be negative 2 because negative 2 plus 2 is 0. And then again, I didn't give you any sort of context, so both of those answers were good to go because neither one is representing any sort of side lengths in a geometric context. All right, the last one. Something interesting is going to happen with this one with the factoring. I just kind of was working with numbers and it just happened. And then I thought, oh, that's actually a really useful type of factoring problem to see. So it happened kind of on accident, and then I decided it would be a good one. So there's definitely more going on with this one when we go to distribute. I don't know how that pen just got so thick. Okay. I'm going to do parentheses for both of these. I'm going to go 3x times x plus 4, and then I'm going to do the distributive property, and then 2x plus 8 in parentheses times x plus 2. The one on the left, I can really just do the straight distributive property. So 3x times x is 3x squared, and then 3x times 4 is 12x. The one on the right, I'm going to do the box thing again. I just really like this method for keeping organized. I find I make less mistakes when I use this method. Unless my pen doesn't want to write. Then it'll be hard to do without making mistakes. All right, 2x plus 8, x plus 2. 2x times x is 2x squared. 8 times x is 8x. 2x times 2 is 4x, and then 2 times 8 is 16. So we have some like terms again. That gives me 2x squared plus 8x and 4x is 12x plus 16. All right, I mentioned when we solve a quadratic equation, we need to get it equal to 0. So this time it's like, well, which side do we deal with? Because there's a lot going on both of the sides. Personally, I like to have x squared be positive. So I'm going to look at these two terms and I'm going to subtract the smaller x squared term from both sides because I don't like factoring when I have a negative x squared term. So I personally am going to subtract 2x squared, even though there's one more thing on that side to have to deal with. All right, this is where it got weird. This is the part that I didn't really mean to happen, but it did, so we're going to go with it. So we're subtracting 12x from both sides, and it actually cancels out on both sides. And then minus 16, there's nothing to combine it with, so we're just going to tack it on the end. So now my right-hand side is equal to 0. And then on the left, I have 3x squareds minus 2x squared is just 1x squared. Minus 16 equals 0. There's a couple different ways to solve this, but I'm just going to go with the factoring method because that's what we've been doing. So this one is funny because there is no middle term. We have to get x squared and we have to get negative 16, but there is no x term like there was for these other ones. So x squared is x and x. And then when you think about like, well, what factors of negative 16 give me no x term? Well, it's if they're opposites. So 16 is a perfect square, 4 times 4. So if you go minus 4 and plus 4, if I were to multiply these out, I'd have negative 4x and positive 4x, which adds up to 0 x's. And that's why there's no term in the middle. So when I solve using my zero product property, x can be +4 or x can be -4. Both solutions work, but again, in a geometric context, be careful when you're plugging stuff back in because we have to have positive side lengths. So hopefully that's a good range of problems. Like I said, one of the problems on the honors assessment is going to deal with a quadratic. And this is something, especially if you're planning to take Algebra 2 honors next year, this type of factoring is something that your teachers will want you to feel comfortable with coming in. So please feel free to email me with any questions or let me know if you want to go over any more examples before the next honors assessment. Thanks for watching. Send me your work so I can give you feedback on it. Bye.